Hey guys, so this is an additional examples video that goes alongside the lessons video where I was talking about Pythagorean and quotient identities. So we're going to look at 3 more examples where I'm going to find all 6 values of the trig functions just using the given information here. So hopefully this helps you wrap your head around this. Our goal is to use the Pythagorean identities, which are here. You can pause if you want to review them, or the quotient identities. So those are going to be very helpful in solving these. Okay, so let's start with cosine of theta equals -3/5, and we know that theta is in quadrant 3. Okay, so to begin, we're going to, let's just go ahead and use our sine squared theta plus cosine squared theta. This equals 1. Okay, so I'm going to go ahead and plug this guy in so that I can figure out what sine squared theta is. So I've got sine squared theta and then plus -3/5 squared, and that's going to equal 1. And so then I just kind of keep working these details out, so I will get that this is, sorry, I can't write today. Okay, this becomes 9/25. So I ultimately have that sine squared theta is 1 minus 9/25. So then I can say sine squared theta is equal to 16/25. Okay, so now I want to take the square root of both sides. And the thing that a lot of people forget is when they take the square root, you actually get 2 answers. So the square root of 16 is 4, the square root of 25 is 5. Okay, so now what do you do with the fact that you have the 2 answers? Well, this is where we have to use this information that we're in quadrant 3. So in quadrant 3 is sine positive or negative. So I talked about how to figure this out in another video, but I made a little cheat sheet chart. So we're talking about sine, it's negative in quadrant 3. And again, you might want to pause and write this down if you find this helpful. So now I can say that I'll just get rid of both those signs and say that my sine of theta is equal to -4/5. Okay, and so now I've found one of my identities. So let me clear some space and then we'll keep going. Okay, and so now we're like in the home stretch, so I can go ahead and use one of the quotient identities now. So tangent of theta is found by taking sine of theta over cosine of theta. So this becomes, let's see, -4/5 over -3/5/5. Told you I can't write today. Okay, so if I work this out, this becomes -4/5 divided by -3/5. So that's -4/5 times -5/3. So then I can cancel out my 5's, and I will get 4/3 as my answer. So I'll just note that over here. So my tangent of theta will be equal to 4/3. Okay, so let me clear some space. And now we really have all the information that we need because I can just use the reciprocal identities. So I'll just remind you, again, you can hit pause on the video if you need to review this. I have a whole video, of course, where I talk about this. So now I can finish this. So I know that cosecant of theta, that's just the reciprocal of sine, so this will be -5/4. Secant is the reciprocal of cosine, so this will be -5/3. And then cotangent of theta, this will be 3/4. So I just take the reciprocal of those 3, and bada bing, bada boom, we're done. Okay, so now I've got cosecant of theta equals 2. Theta is in quadrant 2. Just a reminder, I always think you guys, if you think you've got it, try pausing the video, see if you can do this on your own. You will get so much more out of this video if you practice alongside me. Okay, so you might be thinking, oh, I can go ahead and just write out the reciprocal of this, sine of theta, and then I can use, that Pythagorean identity we were using before. I personally don't want to do this. I like this because 2 is a nice whole number. So I don't want to use, when I think about my options, I actually don't want to use this particular property because then I'm going to have to use that fraction, right? The sine of theta is equal to 1/2. I don't want to use fractions if I don't have to. So instead, what I'm going to use is I'm going to use this property here. So 1 plus cotangent squared theta equals cosecant theta. So 1 plus cotangent squared theta equals cosecant squared theta. And so now I can just plug that in. and I can figure out some other information in this case. So this becomes 2 squared. And so then I can go through and solve this to get that cotangent squared theta is going to be equal to 4 minus 1. So cotangent squared theta equals 3. And so cotangent of theta, what does this equal? This equals, let's see, oh, sorry, plus or minus the square root of 3. So now we have to think about the signs of cotangent in quadrant 2. So in quadrant 2, I've got my handy dandy chart here. So quadrant 2 cotangent is negative. Okay, so I'm going to just restructure this and just write this as the negative part. So I've got that, so I'll just note that here. So cotangent of theta equals negative square root of 3. Okay, and just by the way, if you're wondering why didn't I do that with sine of theta, I just thought this might be a question. So cosecant and sine, since these are reciprocal functions, they're going to have the same sign in that quadrant. So if this one's positive, then so will this one. But, you know, I had to think about the quadrant for cotangent, so hopefully that makes sense. Okay, so let me clear some space. And so now I have to find cosine. I have a lot of different options of how to do that. I think I will use the other Pythagorean identity that I was trying to avoid using. So I'm just kind of doing this on the fly, and so you can see my thought process with things. So I'll just use this. I don't like using fractions, but it's really not the end of the world. So I've got sine squared theta plus cosine squared theta equals 1. So I'll plug in that 1/2 that we found earlier, and I'll go through the motions here. So I get cosine squared theta. This will equal 1 minus 1/4. So cosine squared theta equals 3/4. And so then I have cosine theta is going to be equal to plus or minus the square root of 3 over 2. So I take the square root of the top and the bottom here. And so once again, now I have to think in quadrant 2, is cosine positive or negative? Cosine is negative in quadrant 2. So I'll go ahead and just erase these and note that. And so let's see. Let me clear some space here, and then we can finish. Okay, so I am well on my way now. So I've got to find tangent and secant. So for tangent, so I can just take the reciprocal. Tangent of theta is going to be equal to negative 1 over the square root of 3, although now I have to rationalize. So this will be negative square root of 3 over 3. And then secant of theta, so I can just write this as negative 2 over the square root of 3, and then I have to rationalize. So this becomes negative 2 square root of 3 over 3. And so now we are good. Okay, so for this last one, so I just have cosine of theta equals 1. Now I know just looking at this, it's like, oh, we don't have a quadrant, but let's see if we can figure this out using our identities. So I've got sine squared theta plus cosine squared theta equals 1. So if I plug in the info, look at what we get. We get sine squared theta is going to equal 1 minus 1. So sine squared theta equals 0. So sine of theta equals 0. Okay, so sine of theta equals 0. Let me clear some space. Okay, so next I have tangent of theta is going to be sine of theta over cosine of theta. So that's 0 over 1, so this will just equal 0. So let's see, I'll note that here. Tangent of theta equals 0. And from here, now it's just, using the reciprocal functions. So I'll clear some space. Okay, so using my reciprocal identities, so let's see. Secant of theta is just going to be 1 over 1, so that just equals 1. Cosecant of theta, so the reciprocal of 0 is undefined, so this will be undefined. And then that can also be said of cotangent of theta, so this is also undefined. So we didn't need the quadrant in this case, right? So that's it for this one. And so that covers the examples here. Hopefully that was helpful. Any questions, you can always leave me a comment. Otherwise, I'll talk to you guys later.